All right, welcome back. We're going to talk about work and a special definition of what we call work, which is from physics. And we know that work is just equal to the force that you applied to something multiplied by the distance that it moved. Our basic equation, work equals force times distance. Our units in metric system is newtons, which is a measure of force, times meters. A Newton meter is also called a joule. And in standard units, force is measured in pounds, distance in feet, and we get pound feet is an amount of work. We also have another equation called Hooke's law, and Hooke's law deals specifically with springs. And Hooke's law says that the force applied to a spring to move it a distance x from its resting position, either stretch it or compress it, is equal to a spring constant times the distance that it is stretched. So for our example, we're given that a force of 10 newtons is required to stretch a spring 2 meters. So let's start with that, because that allows us to calculate, given force is equal to a spring constant times distance compressed. This tells us that for this particular spring, 10 newtons is equal to k times 2 meters, which means that the spring constant of this spring is 5 newtons per meter. So we now know the value of the spring constant. So let's think about the work that is being done from 0 to 4. Well, first of all, our work, we're looking at the area underneath this force graph, which means that we're looking at these little rectangles right here. This is my width. This is my force, which is going to be a function of x, how far I stretch it. Notice, coming back to here, the force on this spring is equal to 5 times how far you have stretched it. So the further you stretch it, the more force is required to continue to stretch it. And so when we add up these rectangles, we get the sum of the forces at any given point times the width of the rectangle that we're dealing with. And so we now know that this is the sum of 5x delta x for any given spot. So now we can write our integral. Our integral is the integral from 0 to 4 of 5x dx. This will tell us the amount of work done to stretch the spring from 0, which is uncompressed, to 4 meters of stretch. And we use fundamental theorem of calculus for this one. We get 5 half x squared from 0 to 4, which gives us 5 times 16 over 2, which gives us 40 Newton meters. That is the amount of work needed to stretch the spring out to 4 meters in length. All right, go ahead and do exercise 35, and we'll be back with a chapter recap. Thanks for watching.